Right. In this video, I'm going to explain you how OSPF process work. For that, I am going to use this diagram. In the diagram, I have three LAN network 20.0, 10.0 and the 30.0, and I have WAN link in between two routers R1 and R2. I already assigned the IP. So the purpose of this section to explain how OSPF works, how OSPF exchange the message. So in here, as you know, any dynamic routing protocol has three component, that is routing protocol, message, database and the algorithm. So in here I am going to explain all the routing protocol messages related to the OSPF and databases and how routing table created with that. So the first thing, I need to configure the OSPF here. Still no configuration. So first I go to the simulation mode and I only filter the OSPF packet because I'm going to learn the OSPF how it works, right? For the first, I'm logging with my first router R1, and first thing I need to enable the OSPF with the command route OSPF, and I need to define what is my process ID. After that I can define route ID. Route ID, you know, that is equal to the IP, but that is not the IP address, that has no subnet. That pattern is equal to the IP address, that is only identification value for the router within the OSPF network. You can use any value like this, the pattern equal to the IP version 4 pattern, right? Then I need to enter what are the directly connected network with me. So I have three network, 192.168 10.0 network, wildcard mask, area 0, and I have another network that is 20.0, and I have another network that is 172.16.0.0, wildcard mask is 003 and area 0. So these are the three network that I directly connected. So I enter the OSPF related configuration for the R1, that's okay. Then go to the R2. With R2 again I need to do the same configuration. Enable the protocol route OSPF1, and I define the route ID, let's say 2.2.2.2, different ID, and for that there are two directly connected network, that WAN link and the 30.0 LAN network. So the network 192.168.30.0, area 0, and I have 172.16.0.0 network within the same area. So as you know, OSPF is link state routing protocol. That's not the distance vector, this is link state routing protocol. The main difference in between link state and the distance vector routing protocol, you know, protocol like RIP, they are sharing their entire routing table with each other. So that's the behavior of the distance vector, but this is link state. How link state routing protocol is, how work is, so link state routing protocol never share its routing table, it's only share the link status. So what are the meaning of the link status? Let's say this router has three interfaces, 2 gigabit interfaces and 1 serial interfaces. So these interfaces having the IP address for these interfaces, based on the link speed, OSPF assigns specific cost value. Those information we call link status, right? So within the routing protocol, what happen is all the routers share its own link status with each other using the multicast. So in here, so as I mentioned earlier, any routing protocol, dynamic routing protocol has three parts: routing protocol message, and those messages store within the databases that we call table, and finally we apply the algorithm to the table, then we can find the best path. So in here the first message type is hello message, right? So as I mentioned, This OSPF protocol maintains three tables. One is neighbor table, the second one is database, the third one is routing table. So before I simulate to next step, I'm going to show those tables. Those are empty now. The first command is show IP OSPF neighbors, right? It say I have no neighbor. Then the second one, show IP OSPF database. It say I have only one database, that database related to me. So this is my route ID that I assign. So I have only one database, that is my database. In here, what's the meaning of the database? Database mean my link status. So I have 3 link count in that, right? Because I connected with 3 links, right? So end of the process, I should have other router link state database also. Then that means there should be 2 databases within that after the process. Then finally we can check the routing table, show IP route OSPF, nothing, no routing table related to the OSPF. So I go to first packet. So the important thing is in here, so all the routing protocol you use specific multicast address for the routing process. In here this is OSPF. OSPF actually using 2 multicast address, 224.0.0.5 and the 6. So in here the common IP is 224.0.0.5. So remember, that's the OSPF multicast IP that used for the multicasting. So then it say this is the hello packet. Hello packet is the first packet type within the OSPF messages. So OSPF hello packet, what is this? It's like an introduction. It simply say hello, my name is router 1.1.1.1. it say about me. Then that include other important information. It say I am related to the area 0. It say I have some timer value. So my timer values are, my hello time is 10 seconds and my dead time is 40 seconds. That means I am going to send you hello message every 10 seconds. I'm also waiting for your hello messages, right? So to become the neighbor within the OSPF, both routers area ID and these timer values should be matched. The idea is, if I not receive any hello message from your side for the 40 seconds, I assume you are dead, so I remove all of your information. That's the idea. So this is basically hello message. It's saying hello, I am this router, this is my name, like that. So now hello packet exchange with 2 routers. So now this is my router 2 and this is my router 1. So within the router 1, again I am run the same command, show IP OSPF neighbor. Now you can see, now I have neighbor, but earlier that is empty. Now I have neighbor. I know that neighbor name is 2.2.2.2. So now neighbor table built. Let's go to the second packet. After few seconds, these routers exchange their database information. That packet we called OSPF DD. DD mean database description. So basic idea, this packet say I am having database. So after becoming the neighbors, they are exchanging their database information with each other. Remember, this is not include any link state information. It's only the database description. So after that, what happened? Both are receiving neighbors database description packet. Then those routers going to request that, right? So now my router going to send OSPF link state request. Earlier I mentioned what is link state. Link state means the information about this link. So with the second stage, they share their database description. Now my router going to request, please send me your database. That request we call link state request, LSR packet. That's a type 3 packet. So after that, what happened? After router received the database link state request, these routers going to sorry, not that packet, we'll check. Yes, this is the packet. After those routers requesting, yes, I need your database, that packet we call link state request. We observe that as an answer for the link state request, other routers should send its own database that we call link state update. That's a packet type 4, the fourth one, link state update, because earlier my neighbor request please send me your database, so this is the database, right? So in this packet that include link information and related cost value. So you know OSPF use a specific formula to calculate the link cost. So that is reference bandwidth divided by the link bandwidth. Based on that, for the serial link, that is 64 for any gigabit link that assign the value 1. So you can see what are the link information and the related IP, those link information, link status shared with the OSPF link state update message. So after that, what happened? So I got link state update packet. Finally, I need to say thank you for that. So that is we called link state acknowledgement. I think that is miss. We'll see. Yeah, this is the acknowledgement message. After I receiving my neighbor database, I am simply saying thank you very much for that. I got it. So that we call link state acknowledgement. That's a type 5. So up to now we learned OSPF process start with the hello message. Hello message create the neighbor table. Then those neighbors share their database description. Then after that, what happened? They are requesting their neighbors database with the link state request packet. Then neighbors share their databases with the link state update packet. Finally say got it, I got it. That is acknowledgement. Now when I go to the R1 and when I check the database, now I have two databases, my database and my neighbor database. Now if I run the command show IP route OSPF, I can see I can reach this network, this remote network. This is my R1 router. I have one remote network, that is 30.0. I can reach 30.0 with the cost of 65 using this next hop IP by going out this interface. How this 65? That's because OSPF assigned 64 for the serial link. For this link, that is 1, altogether that is 65. That's the idea. So this is the way how OSPF works. Thank you very much.